packing in solids. Let us now discuss, student, the form of packing which takes place in solid. So packing means how the atoms are arranged inside a solid. So this is categorized in three different forms: one-dimensional close packing, two-dimensional close packing, and three-dimensional close packing. There are three forms of packing: one-dimensional, two-dimensional, three-dimensional. Now this two-dimensional close packing is further subdivided into two-dimensional square close packing and two-dimensional hexagonal close packing. The three-dimensional close packing is of two types. The first type is on the basis of this square close packing. So by help of 2D square close packing, by help of two-dimensional square close packing, and the second type is by the help of two-dimensional hexagonal close packing, 2D hexagonal close packing. Now this hexagonal close packing, by the help of two-dimensional hexagonal close packing, it will be of two forms. When we will talk about two layers, layer of two atoms, first layer and second layer, and second case will be the case of three layers, first, second and third layer. So when second layer is placed over first, and when we will talk about three layers, when third layer is placed over second. Now when third layer will be placed over second layer, two things will be kept in mind. First, tetrahedral voids will be covered, and second, octahedral voids will be covered. So this is the whole flow sheet of packing in solids. Now let us move to one-dimensional close packing. Now what does this 1D close packing means? Student, this one-dimensional close packing means that the atoms are arranged in just one dimension, either x direction, x-axis, or y-axis, or z-axis, student. And there is a term involved here which is called as coordination number. Coordination number simply means, students, coordination number simply means number of neighboring atoms. Coordination number simply means it will be represented by Cn, coordination number, which means simply number of neighboring atoms. कितने सारे पड़ोसी atoms हैं वो coordination number को decide करेगा. So when we talk about one-dimensional close packing, where atoms are just arranged in along one of the axes, either x or y or z, so in this case we have to find out what is the coordination number. What is the coordination number of an atom? So just check out, student, just pick any of the atom. So let me pick this atom. So this atom is in contact with how many atoms? 1 and 2 atoms. This atom, this single atom, is in contact with two atoms, direct in contact with two atoms. So the coordination number here will be equal to 2. The coordination number in 1D close packing, one-dimensional close packing, is equal to 2. Now there could be a question in your mind, sir, what about this last atom? It is just in contact with this atom, but it is not as such, because this atom is further in contact with some another atom, which will be in contact with further some another atom. So the coordination number of the atom in one-dimensional close packing is equal to 2. Now two-dimensional close packing. So two-dimensional close packing, we have two categories, square and then hexagonal. So two-dimensional square close packing. So just check out the arrangement, students, here. Just check out the arrangement here. we have this A type of layer. You can see that this layer is of A type, let it be A type. Then the layer above it is also of A type. So we have all AA type of arrangement, AA type of arrangement, AA type of arrangement. The atoms are arranged in the layers in form of AA type of arrangement, similar type of arrangement. Now, why we call it as square close packing? Why this geometrical word square is included here? So for going through this, you just calculate the coordination number of atom. So let us pick this atom and let us check it is in contact with how many atoms. So it is in contact with this atom, neighboring atom, this, second, third and fourth. So each of this atom, each of the atom is in contact with 4 atoms. You can pick any of the atom. If you will pick this atom, it is in contact with 1, 2, 3 and 4. So the coordination number in 2-dimensional square close packing is 4. Coordination number is 4 here. Now why we call it as a square? So just join the centers of the neighboring atoms, students. Just join the centers of the neighboring atoms. So that I am doing here. I am just joining the centers of the neighboring atom. And let us see what sort of geometry I am getting. So clearly this geometrical figure is a square. So that is why it is called as a square close packing. So this is square close packing has a coordination number of 4. Now let us student move to its second category, 2-dimensional hexagonal close packing. Now just observe the pattern of the layer. If this first layer is of A type, then this layer is obviously of different type, B type. Then the third layer is of A type. Okay, so this layer is of A type, B type, A type. So the type of arrangement here is A, B type of arrangement. So we are just moving along 2 axes, x axis, y axis. We have not taken this layer outward. We have not taken this layer outward. ये layer बाहर नहीं निकला. Z axis की कोई बात ही नहीं हो रही है. We are just taking x axis. We are just taking y axis. Y axis हम लोग ले रहे हैं. इसकी x axis ले रहे हैं. But Z axis की यहाँ पे कोई भी discussion नहीं हो रही है. Z axis तब होगा, 3-dimensional ये तब बनेगा when we will having layer placed above this. इसके ऊपर जब layer place करेंगे तब तो होगा 3-dimensional. अभी तो ये 2-dimensional है, क्योंकि आप देख सकते हो, मैं फिर से बताता हूँ, x axis होगा एक एंड y axis, बट z axis हाइट की ओर हम नहीं बढ़ रहे because there is no any layer above it. So we are talking just about 2 axis, students. Now what is the coordination number? So for calculating the coordination number, let us select an atom. So I have picked this atom. Now let us check it is in contact with how many neighboring atoms. So 1, 2, 3, 4, 5, 6. So the coordination number in case of 2-dimensional hexagonal close packing is 6. So coordination number here is, student, 6. Now why we call it as hexagon? If we join the centers of the neighboring atoms, what we are getting here is a hexagon. That is why we call it as hexagonal close packing. So we have covered till here, student. In this flow sheet we have covered till 2-dimensional close packing. Now let us go through 3-dimensional close packing, where we will take help of first 2D square close packing and then 2D hexagonal close packing. So let us have a discussion over it. This is three-dimensional close packing, 3D close packing. First case, by help of 2D square close packing. So this is two-dimensional square close packing. But students, what we have done, we have made it three-dimensional by putting layers above it. So just observe, student, what is happening. If this is first layer, so this is the similar pattern below it or above it, you may consider second layer, and similar pattern of layer below 2. So similar pattern of layers we are placing one over the other. So obviously it will be three-dimensional because we have x-axis, we are moving along y-axis, but we are putting layers along z-axis also now. We are putting more layers, so we are covering z-axis also. So this is case of 2D square close packing. And what sort of lattice we are getting here? So we have joined the centers of the atoms and we are getting a simple cubic packing. This lattice which we have got by joining the centers of the atoms is simple cubic packing. Now student, what is the coordination number of the atom? So in its own layer, an atom is in contact with 1, 2, 3, 4 atoms. You can just see it very clearly. An atom is in contact with 1, 2, 3, 4 in its own layer, and this atom is again in contact with similar atom which is lying above it. ये एटम जो है इसके ऊपर तो एक बिल्कुल सेम टू सेम लेयर है ना, तो यह एटम अपने ऊपर वाले लेयर के इसी एटम के साथ कांटेक्ट में होगा, और ये लेयर के नीचे भी एक लेयर है सिमिलर पैटर्न की, तो ये वाली लेयर जो है, ये वाली एटम जो है वो अपने नीचे के लेयर के सिमिलर एटम के कांटेक्ट में होगा. So this atom is in contact with 4 atoms, 1, 2, 3, 4 atoms in its own plane, 1 atom above the plane and 1 atom below the plane, which makes a coordination number of 6. So how we are getting it? How we are getting 6? So 4 in its own layer, 4 atoms in its own layer, plus 1 atom above it, 1 atom above from the upper layer, plus 1 atom below layer. So coordination number of 6. Now student, let us work on by help of 2D hexagonal close packing. This we will cover in next video.